Well, hi, good morning, and thanks for joining Shadow and me here in my shop for day 2 with this radio. So at the end of the video yesterday, last video on this radio, first video on this radio, its performance was really surprisingly good. Like really good. Like really good. So last night I took it down to another part of my house where my office is, and I have much better antenna connections there. I set it all up, and I'm able to compare it against other radios and the like, and this thing's performance just went, it totally tanked. I could hardly receive anything with it. So after quite a bit of frustration, I brought it back down here. I set it up in my shop, a more remote location from the antenna that I'm hooking it up to, and son of a gun if it didn't work again, just like it did the first time. Here in my shop, this guy's working great. Why that happened last night, I don't know. It's probably something to do with the antenna connection that I didn't ever figure out, but very, very strange at this point. One thing I did learn about this radio from that experience is there are a pile of signals coming out of it. This thing is radiating out the antenna connection something terrible, and the reason I know that is because I had it hooked up to an SDR radio. They were sharing the antenna, so in effect each radio is connected to the other one's antenna terminals, and each radio has the potential to send signals into the other. And I do this a lot in my house. I have quite a number of radios, 4 or 5, all connected to the same antenna, no special protection, just the same piece of wire connected, just stringing along radio to radio. I use those radios all the time. There's no serious interference from doing that I've ever perceived, except occasionally I hear the local oscillator from one radio or the other, just occasionally. Often I have all the radios tuned to exactly the same frequency, and again, there's no interference. Put this guy in the mix and the story goes crazy. So there's something about this radio, and we're going to take a look at that almost right off the bat. So the other thing I did is I read up a little bit more on this. I found a ham radio operator who wrote a review of this radio. It's easy to find that kind of stuff on the internet. The review he wrote was excellent. Very, very high quality, very, very practical, right down to earth. That review and a number of other comments all match my experience with this radio. You saw me on the last video tune through the shortwave band and pick up stations everywhere along it. And I even questioned, how can this possibly be? What's going on? So the comments I read was, this radio has a big problem with suppressing image signals. And so you find signals reoccurring along the way. I think the situation is much worse. Having looked at it with my SDR and seeing what is coming out, we're going to set it up here in a few minutes. We're going to look at my own SDR here, just a radio with a spectrum display, and we're going to look at what is coming out of this radio. So that's the story. The other thing about it is the comments are not that this is a bad receiver. The comments are that this is a very, very quiet radio. There's very low noise floor, and often the signals are picked up kind of out of the quiet, and that's exactly what this radio was doing yesterday, which I caught on to. It was really quite surprising to me. The signal to noise ratio appears to be fantastic in this radio. How can that be? This really is a very, very low cost multiband radio. It's cheaply constructed. So, but boy, seems to be working well, or is it? So that's what I want to explore. Is this radio working well, or is it just fooling everybody? Now I have somebody trying to escape from my shadow. She's trying. Okay, guys. Well, I think that got on camera. It's almost embarrassing to my wife and I how affectionate our two cats are with each other. They just love each other. Never seen anything like that. Had cats all my adult life. Never had any that really cared for another that much. But those two cats, they call each other, they get together, they look for each other, they play together. Yeah, it's great. Okay, so first thing to do with this radio is get it operating and get the SDR hooked up and just see what's going on here. Oh yeah, one more thing came to mind that I discovered, and I read complaints about this from on the internet, but I discovered it too. This is a dangerous hot chassis radio, a very dangerous hot chassis radio. I don't know if it's because there's a component failure inside it or not, but without really checking it, I think you could light a light bulb off the chassis of this radio. Scary stuff. When I brought it to the other end of my house, for the first time I plugged it in straight into a regular outlet, right? This outlet is an isolation, has an isolation transformer. What that resulted in, because I took my voltmeter with me, just to make sure, sure enough, I was able to measure full line voltage. And like true to form with a one of these radios, with the radio switched off, you can measure that voltage. You can reverse the plug, the voltage will disappear. You switch the radio on, the voltage will reappear. Yeah. So these are not easy things to make safe. I was quite anxious. So in the end, I ended up plugging this into another isolation transformer. I have a second one. And I ran it on an isolation transformer. I just got so nervous. And the other thing I noticed is when it's plugged in the wall, there's quite a hum on it. Plugged in the isolation transformer, like it is here, that same hum doesn't appear. So whether this is, again, because there's things in the radio that aren't correct, and so these problems are presenting themselves, or whether this is just the way these radios are, I don't know. Don't know the answer to that question. It was also remarked that the radio has great sensitivity, and that certainly is what it appears to me. So, right, I just wanted to make sure I mentioned a hot chassis concern with this radio. That's all. I just wanted to make sure that was clearly stated. My cat has returned. So what we're going to do here, we're going to look at the SDR first without this radio operating. Radio switched off. This is the SDR antenna lead. This is the SDR antenna lead. This is the antenna going out to the house. So just have it straight through to the SDR antenna. Let's take a look at it and we'll see what's on it now. Okay, so we're looking at the low end of the spectrum. 0 here actually means 0 hertz. So we're looking all the way up to not quite 2 million hertz. When the most you can see on this SDR is about 2 million hertz. I thought it was 1 million actually, but 2 million across here. That's pretty good. So here's the entire AM band. Now just look at all this stuff here. These are not radio signals from broadcasters. Most of this is noise. In amongst this huge peaks of noise are stations. Now, just take a look right here. And you see on the right, and there's two signals in there. One of them is going to be exactly on the tens. Let's just see if we can get this on here. So that's the taller peak. That's at 685. And the lesser peak, 680. 680 is a station. That's actually a station right there. You barely hear it because of all the noise beside it. This is what radios are fighting with in my house, in my shop, and on this antenna in the AM band. Now if we go up, and this is typical in people's homes these days. We go up, so now we're going from basically 2 megahertz up to not quite 4. You see a huge drop in the noise signals. It's quite a bit different up here. Still lots of noise. What exactly is this? Let's listen. Well, it's either Cuba or Radio Marti. Well, most likely, almost 100% for sure. So there we are. So you can see the SDR is working like a radio. Let's go back down the AM area. That's where we're going to start with our little experiment here. Now, if I were to tune through there, you just hear piles of noise and occasionally the odd station. That's about all you get out of that SDR. So now we're going to switch. We're going to stop paying attention to the SDR and switch to the radio here. Okay, so I'm going to leave the SDR connected. I'm going to connect these. I'll show you what I'm going to do. To the antenna. This has got a link in it. So we will treat this like a long wire antenna. This is the incoming antenna. Well, normally a long wire antenna would have only one lead, and that would be it. Well, I'm just going to clip this here. Should I open the link here? Perhaps. We're going to save that. I happen to know that this is just the same as connecting to the chassis. So I'm going to do that. If you had a 300 ohm balanced antenna, I think you open the link and you connect between these two terminals. If you have a ground that you want to hook up, you hook it up to the chassis. But this hot chassis situation here, so not in my shop though. And the SDR does not issue signals. I'm not worried about connecting it to the radio. So now we got both radios just connected straight to the same antenna. Are we ready here? So let me show you one of these tags here. That's a company I used to work for, Toronto Hydroelectric System. Do not operate. Great big tag. There's a hole in the middle of it. That's so you can hang it right on the switch of the control panel or wherever you are where somebody can operate a switch. But do not operate. I'm going to explain how this provides safety. So let's say you're a lineman, you're working on a pole, you're working right on a high voltage line, but the line is shut off. Now the switch is maybe a quarter of a mile away inside a little power station. The switch might even be automatically or remotely operated by a control guy in a control room somewhere. How are you going to keep that power from coming on while you're working on that wire? Personally, knowing what I know, I wouldn't go near it. Because what's stopping somebody from hitting that switch? From making a mistake? Goodness knows I'm the guy who makes mistakes. And hitting that switch, and you're holding on to some 8,000 volt wire, that's the end of your career. So what you do is you're the worker out on the line. You drive to that power station. You go into the control panel. You write your name on here, tagged by Jim. Remarks, maybe some remarks. Circuit, to avoid confusion. Switch number 7 or whatever you would write here. And the date, of course. And then you hang that right on the control panel. Right on the switch. Now Bob comes into the station a couple hours later and he's got orders to operate the switch. But he's a little confused. He's got his hand on the wrong switch and you got your hand on that wire a quarter mile away. What's he going to do? This is hanging there. He's going to see this. Do not operate. This one says tagged for control authority. So let's just ignore that for a minute. You're going to see tagged by so-and-so. The rule is you can't operate that switch till you talk to that guy. That guy. And that guy is out on the line working. What you would actually do is you get on the radio, you call your control center. And you'd say, okay, so I got a tag here in the station for so-and-so feeder. Is so-and-so still need it? And then the control center would radio the guy. And the guy would say, no, in fact, you know what? We're in the truck. We're driving towards the station now. We don't need this anymore. I relinquish my tag. Or, maybe in some companies, the guy who signed it is the guy who physically removes it. No one else can remove it. No one else can touch it. So the tagged for control authority means the tag was put on at the direction of the control authority, a guy in the control center, a operator or something like that, a controller, I think is what they would be called. So if you encounter this tag out in the field, this can be hanging from a switch on a pole in the wind, and you show up and it says, hey, tag for control authority. What's this all about? I didn't know about this. You call up the control authority and they will have records, of course, that they maintain. We'll tell them why that tag is hanging there. You can't remove it. Only control authority or the name on it. This is how linemen stay safe. I'm sure it's very similar all over the place, and many industries use this technique in an electrical environment. The deal is, whoever signs that owns the tag and owns the switch while this is hanging on it. So I thought they'd tell you this, just you wonder how people stay safe. Here's another one. I've got a bunch of these I grabbed. So this is a bit of a different one. You see, there's no name on it. Oh, there is a name on it. Now, do they use exactly these tags still? I don't know. These are 10, 15, 20 years out of date. But okay, so I turned this on. Did anything happen? Ooh, that didn't sound very good at all. Oops, sorry about that. Okay, we're on the AM band. So that's 640. That's the very same station. No, it isn't. So this is the station we saw with the two little peaks that were really close together, and the lower one was the station. Here it is here on this radio. Okay, just a quick tour through the hair 590. Lots of funny sounds. You'd never ever hear any of that kind of stuff on an AM radio when I was a kid. Funny sounds like that. Okay, so what I'm going to do now, I'm going to leave this radio tuned up here. We're going to look back at the SDR. The SDR antenna is hooked up right to the antenna, right to the antenna on here and the antenna outside. Then I'm just going to tune this back, and we're just going to watch the SDR. And then I'll have egg on my face because these things never work when you want them to, do they? Okay, so I'm starting to tune down. I'm tuning down. So on the right side of the screen you can see the local oscillator going back and forth now, and I'm tuning back and forth. So I can tell you there's nothing happening here that is anything like what I saw. This is all looking pretty normal. But it wasn't on this band that I saw this effect, so this is all pretty normal stuff here. Now I'm going to shut off the other radio. You'll see the local oscillator disappear, and see what else disappears at the same time, if anything. The waterfall display will show you what has disappeared. Not too much. Turn it back on. You can see a few things come in. A little bit. Not too much. Now, I'm going to go up to the, I'm going to put 6 megahertz on the SDR here. The red line is at 6 megahertz, or very, very close. There, 6 megahertz. Now with the radio, the old radio is what you're hearing. With the radio still on the broadcast band, I'm going to tune it. I'm looking for effects on here. And I don't see anything happening at all. Oh, what's that? Right around 6.3 what was that, 555 megahertz, 5.55 megahertz. So I'm tuning the radio back and forth. So there is a signal coming out of this radio at 6 megahertz. The radio is tuned, well, you know what, I'm tuning just below 5, so that's got to be the local oscillator. If I put the radio, wow, put the radio on 5. Wait a minute, that local oscillator is way out of there. It should be, if I got it to 5 megahertz, you should see it about 5.5, not 6.7. I'm probably confused about which band I'm on here. I don't think so. There's another thing coming down. But this is not, again, what I saw last night. What I saw last night was wild stuff. So let's go up another band here. Now we're on the 5 to 14 megahertz band. We're still looking at 6 megahertz and I'm tuning the radio. Something going through there, coming out of this radio. I'm tuning around 6 megahertz. So that was a local oscillator. Let's go back and see. So that thing that's coming along right, stopping at 6.2. The radio is trying to receive 8 megahertz. So that shouldn't be the local oscillator location at all. It should be 7 something. If I want the local oscillator to appear, I should tune down this range. Just 1 second here. You know what? Something funny about this band button. Just 1 sec. Okay, I'm going to take it all back here. Got myself confused on what band I was on. Or did I? Okay, so now the radio, you can see something coming past 6 megahertz. The radio is tuning around 2.5. 2.5, so that's double the oscillator. Double the local oscillator we're seeing there. Is that so? If I tune way over here, another one going the wrong way there. Should be another bigger one coming in from the left. Any time now. That's probably it there. So now the radio is trying to tune in about a little above 5 megahertz, and there's something at the back. Oh, it's still way too high. 6.2. And we can't see on the SDR. I'm going to move the SDR. I'm going to shift it over a bit. I think we see the real local oscillator showing up there. That's right around 4.6 now. 4.6, and we're tuning. You know what? That'd be correct. So the local oscillator is that big one, of course, but all these other ones. So this radio is known for picking up images, but it might not be images. It might be that it has more than one sort of local oscillator frequency going at the same time. How that would be, I don't know. That's what we're trying to explore. Okay, let's go way up. This is not what I saw, though, last night. What I saw last night was a lot more interesting than all this stuff. So let's go up around 10. 10. Okay, so I'm going to double, let's see, okay. So the band we're on now is the 5 to 14 for sure. Frequency, 5 megahertz to 14. Betcha that's the local oscillator just off around 11. See, we're tuned in on the dial 13 megahertz. So the local oscillator would normally be above, but it may not be. So assuming it's above, it should be at 13,500. What's that thing doing there? You can hear me tune the radio here. So it's just a pile. Okay, so I'm going to tune down. Let's say if I tune the radio to 10 megahertz, which I'm doing now. Okay, there should be a local oscillator at 1045 or like a 10445 or 9. You know what? I think it's below. No, that's not the local oscillator. The reason I know is I'm tuning the radio down and that frequency is going up. Now there's another one there. that's going up. So that one is right around 10 right now. The radio is trying to tune close to 11. What is going on in this radio? Now, what I want to show you, there's a little bit of it showing up now. So you can see the big local oscillator. But if you look to the right of that, around 10.750 and 11, you'll see some peaks there. Now, put your eye on those, and I'm going to tune this old radio. Now there's something worth thinking about. What is being dragged along here? That's the radio. Let me tune a little better. See that station come right out of nothing. There's no hiss. It didn't even expect. I thought the volume was right down. Turn it up a bit. The problem with this is I have the radio tuned on the dial to around 11 megahertz. There shouldn't be any of this stuff there. So this is the whole thing. This radio picks up stuff where there isn't stuff. It does a good job of it. Okay, I'm going to tune around some more here. Going down, down, down. See that thing going up? Yeah, I used to imagine that all these weird signals were artifacts of the SDR. Now I believe these are all artifacts of these super heterodyne radios. Look at all that stuff. Where'd all that stuff come from? All that little stuff. Look at that. Now I'll tune slowly. Look what's going on here. Just tuning slowly down from about 9 megahertz. Look at all that stuff in there. My cat is trying to see in the back of the radio. I guess he's listening. She's listening to me here. So that last part, this is all I was doing. Still have another band to check. I'm going to change it. I'm going to try to get the SDR to come up in this part of the screen here, so we can see both the radio and the SDR at the same time. What do you think, Shadow? Good idea? Okay, let's try this, and we'll see how this works. You can see, you can't quite see what I'm doing. Be able to see my hands on the controls here. There we are. That's amazing. It just comes out of nowhere. So the band we're on this band, tuned right around 8 megahertz, supposedly. Of course, there shouldn't have been any shortwave station there. Sound like the same one? Some of those frequencies you see racing across the screen there are moving at a much higher rate in terms of frequency than I'm tuning this radio. So that's some kind of thing going on in the mixer tube, I have to imagine. Remember the SDR is a radio with its own its own stuff. So there's AVC effects and things going on with that radio too. Well, wow. So is this first of all, is this a problem? I don't think it's not. You know, the fact that it's issuing signals out the antenna is not a problem for this radio. It's a problem for every other radio near it. Is that a bad performance? Virtually any radio that's going to be made, the engineers are going to be sensitive to this idea of having the local oscillator end up on the antenna. Back in the day, radios like this certainly, and many other radios, had outdoor antennas. People regularly had outdoor antennas. And if your local oscillator was wailing away on your outdoor antenna, it's going to be picked up by your neighbors. So efforts were made to do that kind of thing. Sometimes some radios actually have traps in them to trap the IF frequency, either on the way in from the antenna or on the way out to the antenna. So basically, I don't think this radio should be doing this. I think when it was designed, the intention was to have it not do these things. Is it a consequence of its very cheap design? It doesn't have a front-end RF tube, so essentially the antenna is connected right to, more or less connected right to the signal grid of the mixer tube. Well, it can't help. I don't know. I think this is really interesting stuff to explore, but I can't say I've ever seen a radio so bad as this one in terms of pumping signals out the antenna, and at the same time the radio is fun to use because it's picking up stuff everywhere. Now, this might be really here. Let's check. That looks like 6.25. 6.25. So we'll look on this radio.
Autogobierno que habría de establecer un precedente del gobierno colonia.
Roughly. Is it here? Okay, so that's the SDR. So we're listening to Radio Marti. The frequency is it's not on the screen there. 5980. This is really 5980. Radio Marti is the propaganda station from the United States targeting Cuba. Or as I've said before, some might say targeting Florida. Is it really down here too? This is where it's supposed to be. So I mean, there's probably no question that this radio's alignment's way out. So we get one there. Let's go up and just get another station. This is pretty tough at this frequency at this time of day. I don't think I'm going to find something. Okay, we'll go away from there. There should be stations up in here. That's so suspicious. Okay, maybe higher. It's for Chinese people singing for joy because they overcame COVID. That's not supposed to be there. Where is that signal actually? So see if we can find it on the SDR. This is around 11, according to that, but it can't be around 11. Hey, believe it, I found it. So, on the SDR, here it is. 9570. It's actually down here. So, it looks like the oscillator is just getting farther and farther out. It could just be an oscillator adjustment that's required. Should explain why we're not hearing them down here, because they're all up here. Reception's fantastic with this radio. So this is not a serious problem. This is not an image. This is not a. It's just the local oscillator is not adjusted correctly. Bring it in here. Okay. One station. The hiss come up. The hiss came up, and then we got this guy. There's no shortwave stations at 8. So what we're going to do, we're going to find the local oscillator and calculate.
Manos limpias porque este virus se puede transferir, cosas contaminadas que uno toca con la mano y después trae la mano a la cara, la boca, la nariz, los ojos, que te puede contaminar.
So I think that's the local oscillator we see on the SDR at about 7.9. 7.9 take away 455, and you get 465, 7465. It's possible there's a station at 7465. Let's go and see. I did my math a little loose here. That's probably it there. Yeah, it's the same station. Radio Marti again. Seven 435. So it's just a local oscillator. It's high all the way along here. That's a real station. I'd say this is real. Is that the same station? What is that?
Es Poder, un programa de motivación y auto, conducido por la licenciada Dramas. Aprenda a tomar sus propias
The tonal quality is different. This is got more bass. Oh my gosh, how did this get so loud?
Poder, con la licenciada
This
Alexandra
must be another. It must be broadcasting too.
Adolescentes están casi siempre amor. ¿Y qué hacer con ellos?
Okay, let's look on the SDR then. 2? There's no 2 here. There's no 2 here. How far was I tuning there? I'm tuning, wow. Okay, so that's 1,000,000, so 500. I'm tuning quite a distance there. That little wiggle is quite a distance. So maybe I am tuning from one to the other. Listen to the SDR. Yeah. Yeah. So it's real. Well, that's ham radio there. Sideband. This radio is supposed to be able to pick up sideband, but the word is it's really, really poor. So what am I finding out? So what's that? Well, it's roughly exactly where I've got the radio tuned. I'm near 7.9. 7.9, and that big thing is at 7.8. That's a whopper of a signal. And it's definitely from this radio. Yes. So what is that doing there? So it could be, so I think the local oscillator is running way high. So in this position, the local oscillator is running up around here. But on the screen, I've got something right there, 7.8. Okay, let me see if there is one up here. I'm gonna go hunting with the SDR. I'm gonna drag this sideways here. Well, is that it in the middle of the 9? No. So if you're tuned to 8, you'd expect this to be about 8.5. 8.5. It's way down here. Wasn't I finding it above high before? Holy smokes. This is really pretty darned confused here. So radio makers have a choice of whether they want to put the local oscillator below the target frequency or above the target frequency. Usually it's above. Not always though. Now that's interesting. I've never done that before. Just listened to the local oscillator. Listen again, or what I imagine to be the local oscillator. Listen to this. Well, I'd have to guess that's a hummy son of a gun. That oscillation is not a nice pure whatever it is. It's got lots of hum in it. That can't be good for it. It had a hum blasting away inside the local oscillator. What would that do? I think you would hear it coming out the speaker whenever you tuned anything in. What was that? Okay, that's going in the wrong direction. And you can hear it on the, that's the SDR that's making that flop sound. It's a real signal. Here's another one coming. Yeah. And what is going on when that happens? Wait a minute, I heard something. So you're hearing the SDR. What's on the regular radio? Nothing. Wow. Okay. So, I'm making all these observations, but they're not adding up to much in my head. The fact that these things can be put right on top of each other, and then I can tune the SDR. So my intention is to get myself into a position where I can explain all this stuff in perfect detail. The fact that there's multiple signals. The fact that they all come together at times like this. The fact that some go up, some go down. The fact that some move at one rate and others move at apparently double, triple, or quadruple that rate. I think all this is because of that mixer tube. How it gets back to the antenna, I'm not exactly sure, but I'm going to guess weak capacitors that should be killing this kind of stuff. Not doing it. Now the thing that's coming in from the right, I'm turning the knob the other direction. Look at that thing. Now, some of this could be overloading of the SDR. Too much signal strength for the SDR. Don't think that's what's happening here. So another mystery signals. Signals a galore in here. Look at this stuff. Wow. So some of those shapes could be, again, the SDR doing its best to handle this whopper of a signal that's being sent to it. Why am I hearing something? So the SDR is sitting on top of some kind of signal that's not changing with this. Oh. Wow, that's just the strangest thing. There it is, and then when I tune above a certain point, it seems to get caught in something and swept aside. And then back. And there it is. Whoa, baby. Okay. Yeah. You know, it's like somebody took 10 puzzles, you know, like puzzles you do on your card table, and threw all the puzzle parts into one box, shook them all up, and said, there you go. There's only one puzzle in here. Good luck. I am ready for more pain. Let's try another band. So I've now switched it to this top band. 13 to 30. Goodness knows we shouldn't hear anything on that. So this is, with the SDR, we're still looking back at 8 megahertz. And I'm tuning up to 24. So I mean, there's just look at this thing. So I mean, this will work. If this is in the radio in the wrong spot, it's going to work like a local oscillator. This is why this radio is full of images. They're not images because the local oscillator is producing too many oscillations. And we might get something. I can hear that thing again in the SDR. And then it gets waylaid by this. Let's go down to the this is 17 to 5 million. Oh my gosh, there's just stuff everywhere in there. Oh. Right on the broadcast band. Doesn't seem to do much. A little bit there going. It's nothing like the other bands. Okay, wow, okay. that was more exploring than I expected. Let's just jump bands here. I put this in the middle. We're just going to flip bands and watch what happens. So we're down on the broadcast band, but we're looking at the shortwave band on the SDR. Switch off. Okay, so that was pretty interesting to me. I'm always curious about these kinds of things. So pretty convinced this radio is issuing all kinds of signals out its antenna. I'm also pretty convinced its alignment is way off, especially a local oscillator alignment. The actual receiving performance of the radio is still pretty good, except it receives stuff where there isn't stuff, so there's multiple local oscillator frequencies in here. Why would all this be? Bad capacitors all around? Could be. Is it worth working more on? Oh yeah, for sure. This is a fun radio. I think I'm going to have lots of fun with it. So I'm going to stop at this point and go and think about what the next observation should be, or should I start monkeying around with it and see if we can spot what generates all this stuff. How would I ever come to grips with where all this is coming from in the radio? And maybe it's coming from multiple sources, or is it just one capacitor and it's all cleaned up? Well, I'm going to go away and think about all those things. Okay, well, I did get an idea for another way to test this, and that is to just leave the tuning in one spot on the radio and vary the antenna signal with this signal generator. So I'm all set up for that. So where are we starting here? Starting on the broadcast band, tuned to about 900. And I'm just going to whip this around. When we pass 900, you should hear it. Otherwise, you really shouldn't. I'm going to put the signal moderately high to start with. Shouldn't be too high for a radio like this. Should be okay. Okay, so that's the end of my band here. So we heard it coming in, didn't hear anything else, except that really crummy hum there. Seems to be only on the broadcast band. Okay, but it is receiving poorly. I'm more interested in these other bands, so we'll switch up to band 2. Have I got these band numbers backwards again? No. No. So we're on band 2. In the middle, we're tuned just below 3 megahertz. I'm just tuned around here. Make sure we got this loud enough to hear anything. Well, that's surprising, eh? Well, you can't see that. Come on. So I'm in the middle of the AM broadcast band. The radio is tuned to almost 3 megahertz. So what's happening is, every time you hear a tone come out of here, that means that the signal coming out of the signal generator has been mixed down to the IF frequency somehow, against some other signal, something going on. Shouldn't hear any of this. What that also means is if there is a radio station of the appropriate frequency sitting on the antenna on the AM band while I'm tuned on shortwave, I will hear it or hear effects from it. So this kind of thing happens from overdriving the front end of a radio. So one of the tubes is no longer operating in the linear portion of its characteristic curve. You get into the curved part and harmonics start coming out. Is that what's going on here? I got no idea. So let's go up another band. I'm still really low here. Let's go up here. So now I'm in the range that we're actually tuned to. So I'm not going to analyze all these. I'm just going to become aware of them. That. Okay, let's go band 3. Just down through this range. We're tuned to around 8 now. That's probably what we're tuned to. That might be half. Oh my gosh. This radio has big problems here. Okay, let's go to the top band. Haven't heard much from this one. It's just got that characteristic high impedance hum, I would call that. And staying in the same frequency range. I set to 20. Coming down from 30. So everywhere you hear that tone, if there's an actual radio station at that location, it would come in right now on this radio. A strong enough one. Tuned around 20. So. Okay. So radios have a way of picking up a signal called the image signal. And the way that works, in case you don't know, and I'll see if I can explain this really simply. So you have the signal you're after. You have the IF frequency way down here. This would be 455. This might be, let's say, 5 megahertz. And then you've got the local oscillator. And what you're trying to do is move the when you tune the radio, you're moving the local oscillator around until it's 455 kilohertz apart. And then you get a 455 kilohertz signal out of here. Well, what if there's more than one of these? Oh, it's going to explain the image. So there's another place where a signal can produce the 455. And even though you're targeting this one to tune in, there could be another one sitting up here. Exactly 455 apart. And as you tune in this one, you'll tune in this one too. Now normally what radios do is they focus their attention on the desired signal. And I'm trying to draw the response curve over top of this. And so that response curve comes down, 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 down. By the time you get to this signal, the radio is so weak it can't really reproduce it, and you just won't hear it. Not so with this radio. So that's an image thing. But I also think what's going on in here, and I'm not sure, is there are other oscillations in the radio that are acting like local oscillator signals. So along with this arrangement, you've got another oscillator over here, which might end up being, that's too much of a weird situation. You have another oscillator going over here. You have another signal down here, you have this response curve which may be very broad in this radio. You get 455 between these, it's going to come out the speaker. Again, greatly diminished, but only if. So there we are, image frequency. So if you want to know more about that, you don't know what I'm talking about, just read on the internet for sure. But it's something, it's a little tricky to understand at first what's going on. It's mysterious when you tune a radio because you hear a station, you don't necessarily become suspicious it's coming from some problem in the radio. Especially this one, because it reproduces them so nicely. It's pleasant to listen to regardless of where they come in on the band. Okay, so maybe all these effects are because of bad capacitors in this radio. Maybe. And maybe we can study the schematic and get a grip on who might be responsible for this kind of problem. And maybe we can target 1 or 2 replacements and see this radio clean right up. It has a reputation for the kind of behavior I demonstrated today. So I think we're going to look at it from that point of view. Interesting radio. Well, thanks for watching this video. I think I'm going to cut it here, and we'll do the capacitor thing. The next time working on this, we'll go through the analysis of which capacitor might be responsible for what. Start doing some targeted changes in here, and like I said, see if we can make all those ghostly things disappear.